All right, let's pull back the curtain on a piece of tech that you've probably never seen, but trust me, it's making our entire world run. We're talking about the variable frequency drive, or VFD. Think of it as the hidden brain that's quietly making everything from the AC in your office to your city's water supply smarter, smoother, and way more efficient.
So to really get why VFDs are such a game changer, we have to start with the problem they were built to solve. And it's a pretty big one, a fundamental issue with most of the electric motors that power, well, everything.
Seriously, think about this for a second. What if your car didn't have an accelerator pedal? Just a big on-off switch. You're either completely stopped or you're flooring it at full power. No gentle starts, no cruising down the highway. It would be wild, right? Jerky, super inefficient, and it would put so much stress on the engine. Well, that's pretty much how most basic AC motors work. It's all or nothing.
And this comparison just lays it all out. A standard motor is really just a brute force tool. It slams on, pulls this huge surge of electricity, and it only knows one speed, flat out. But when you add a VFD, that motor becomes a smart motor. Now it can change its speed, it can start and stop smoothly, and it becomes incredibly efficient because it's only using the exact amount of power it needs for the job.
So, how do you give that simple one-speed motor the kind of finesse you'd get from a multi-gear transmission? You give it a VFD.
At its heart, a VFD is basically a sophisticated power translator. It sits right between the power grid and the motor itself, and by precisely changing the electrical frequency it sends out, it gets to control the motor's speed. And that's the key thing to remember here. For these kinds of motors, frequency is speed. You know, I absolutely love this analogy because it's spot on. The motor is the muscle, it's strong, it's simple. The VFD, that's the brain. It's telling that muscle exactly how fast and how hard it needs to work at any given moment. It's what adds intelligence to all that raw power.
Okay, so how does this brain actually do its job? It might sound super complicated, but it's actually just a really clever three-step process of manipulating electricity. Let's break it down.
So here are the three big stages. First, the VFD grabs the standard AC power from the wall and turns it into DC power. Second, it takes that DC power and cleans it up, makes it really stable. And then, for the final and coolest step, it chops up that clean DC power to build a brand new, custom-made AC signal to send to the motor.
So, step one is the rectifier. The AC power coming in alternates, right? It flows forwards and backwards. The rectifier uses these components called diodes. Just think of them like one-way gates for electricity, to force all of that power to flow in a single direction. This turns that nice alternating wave into a kind of bumpy, pulsating direct current.
But that bumpy DC power isn't very useful yet, so that's where the filter comes in. It uses these big capacitors that work just like a water reservoir in a plumbing system. They absorb the peaks of the power and fill in the valleys. And what you get out of it is a smooth, stable supply of DC power. It's a clean slate to work with.
And this right here is the million-dollar question. We've got this clean, steady DC power, but the motor needs variable AC power to control its speed. How in the world do you create that from a steady DC source?
Well, the answer is a technique with a pretty fancy name, but a really simple concept: pulse width modulation, or PWM. This is where the real magic inside the VFD happens. Think about it like this. Imagine you have a light switch. To dim a bulb, you could just flick that switch on and off incredibly fast. By changing the width of the on pulses compared to the off gaps, you control the average power going to the bulb and therefore its brightness. The VFD's inverter does exactly that, but thousands of times every second. By timing these pulses perfectly, it fakes a smooth, brand new AC sine wave at any frequency it wants.
Okay, so we've covered the how, but let's talk about the why. Why go to all this trouble? Well, the payoff is absolutely huge, and it all starts with saving energy. A lot of energy. Get a load of this number. 65% of all industrial power is eaten up by electric motors. That's just staggering. So any little bit of efficiency we can gain here has this massive ripple effect on everything from a company's bottom line to the stability of our entire power grid.
And this is the headline number right here. By using a VFD to perfectly match a motor's speed to the actual work it needs to do, say on a fan or a pump, you can slash its energy use by as much as 70%. That's insane. This one technology is one of our biggest tools for shrinking the carbon footprint of our industries.
Hey, remember that full throttle start we talked about with the car? A standard motor draws 6 to 8 times its normal running current just to get going. That initial shock just hammers the electrical system and all the mechanical parts. A VFD, though, it gives a smooth, gentle ramp-up. It uses way less starting current and dramatically reduces all that wear and tear.
And honestly, the benefits just keep stacking up. Smoother operation means your equipment lasts longer and you have to do less maintenance. You get way more precise control over your processes, you get less noise and vibration, and you make more efficient use of the power from the grid. It is simply a win-win-win across the board.
Now, you might be thinking this is all just for giant factories in industrial plants, but the truth is, these hidden brains are absolutely all around you. That fan in your office building's air conditioning system, the escalator at the mall, the elevator in your apartment building, the pumps that bring you clean drinking water, yep, all of them are increasingly being controlled by VFDs to make them run smoother, quieter, and so much more efficiently.
So, here's the big takeaway. VFD technology takes one of the most common devices on the entire planet, the electric motor, and it makes it intelligent. So now that you're in on the secret, you start seeing the possibilities everywhere. So I'll leave you with this. Where else could smarter motors totally change our world?